So, hi, I'm Alex, co founder and CEO of the United Manufacturing Hub, and I'm happy to share today another episode of the Connected Factory podcast. Today I have Kasper with me. Kasper owns the Industrial IoT initiative there as a platform owner, and I'm super stoked to let him tell you what went well, what didn't, and how it's currently looking like to a little bit give you guidance and also inspiration on how to build your UNS or other digital initiatives. Let's jump into it.
Yeah, I can do that. Yeah, my name is Casper, and the middle name is Korsholm Christiansen. It's not very easy to pronounce if you're not from the Nordics. But yes, living in Denmark, working at Velux as a senior platform owner of our IoT platform. I am educated as actually an electrician back in the days, but always been working with machinery, and for the last as a PLC programmer and then project manager of buying machinery and building machines. But for the last 10 years, I have mainly worked with integrating machines with IT in different ways and had a lot of learnings on that, I can say, in those 10 years, good and bad. Yeah, and personally, I live here on the west side of Denmark, close to the sea, in a small town. It's called Skjern, where we also have Velux has one of its European factories, which is also where I have my daily office. Today I'm sitting at home, but normally I'm at the office. Live with my wife and 2 kids, and in my free time I watch handball. I go hunting. I do a lot of CrossFit. Have to say that. I know that's. And then I am trying to learn to play guitar. That's not going very well. If you wanted to practice how to fail fast, you need to buy a guitar. At least if you're like me, I've never been musical introduced.
Yeah, I wished at that time my parents back then would be more Asian parent style and forced me to don't stop learning. I was also trying to play guitar, but then as a teenager was obviously more interesting stuff to do than that, so I dropped out and I regret it every day. I should don't learn it more. Actually, it's super interesting pattern, this electrician to industrial IoT. So it sounds a little bit counterintuitive on the first glance because it's normally electricity that you work with, and now you're working with Kubernetes and highly distributed IT systems. So what actually make that the transition logical and easy for you? So why do you think others and perhaps you specifically actually moved from electrician to IoT?
Yeah, that was also quite a journey, you can say. It was not like from day one. It was like when I started studying to be electrician, I thought also that was what I was going to do. I was just starting, you can say, building houses and doing wiring and lamps and all of that. And then suddenly I found out, okay, you can actually also build machines. And then I started repairing some machines and some. The company where I was an apprentice, we had some contract with some industrial companies where we had to maintain the machines. So I quite soon found out that that was a little bit more fun, a little bit more complex to do. And then I did my couple of first automation projects, smaller ones for some local industrial companies. And then I found out you could actually program the PLCs, and that was quite. Was probably also a little bit nerdy back then, playing a lot of computer and stuff. So that fit well with me, and so I actually changed my apprenticeship to being, you can say, going from in Denmark what you call, there was like different branches of electricians. You could either be going for the building, and you could go for the industry and automation. And I changed my apprenticeship to look more on the automation and side of it. And when I was done with my education, I actually wanted to become a machine engineer. And but before doing that, I needed to earn a little bit of money, and so I found a job at Velux. So okay, I'll just stay here 1-2 years and earn some money, and then I will go to university. But I think I was at Velux for half a year maybe, and then they said, "Oh, we actually need a PLC programmer. Could you do that?" And I was like, "Oh, that was actually what I wanted to study for, was to actually that I could do programming." But actually, they offered me after like half a year that I could do that full time, and then I basically just learned to program by myself, or you can say, or by looking at my colleagues back then in Velux, how they did it.
I really like this hands-on approach, and if I would try to map out a little bit the customers and community members that we know, it's often either or. So you're starting from the IT perspective, like cloud native world, and try to push the data, just the data of the machines in there, but then neglecting often that this is more complicated than that, in sense of what actually data types you want, how the machine works, which are the relevant KPIs, if they're not already there, how you get it out. And or like the other way, I would say OT focus, where they just push everything into so-called MES and try to make a use of the data there. And I really like the approach on coming from the machine, but like you will also share later, to try to match it with IT, like really proven and I would scalable technologies to make it work. So really interesting, and also would say a similar pattern. Don't specifically know why, but it's super interesting. And how do you start it now from, electrician, like dip your toes into PLC programming, and then now it's the next step, industrial IoT. What was the ignition point for that, and why do you start using, and why Velux actually prioritize something like that?
Yeah, I think it's maybe a little bit of coincidence. You can say I've been in Velux for 16 years now, but in the big, I think within the last 10 years, we also saw there was also our factories were requesting more and more solutions where the machines were talking together with our ERP system, more advanced solutions, and so we had these projects coming up, or a lot of times where we have bought this new machine, could you connect it to the SAP, or could you connect it to the next machine, or could you build some RFID tags to do some tracking and tracing of this. And I don't know why, but somehow in the beginning I got part of those projects, and for a long period when we had those projects, they sort of landed at me, and I was and a couple of colleagues that I worked very close to. So I just simply gained a lot of knowledge in those kind of projects. I've also done machines from you can say, been part of in Velux we have two departments that is actually also building our own production equipment from the ground up, doing the drawings, the testing, building, and doing the FAT and SAT and all of that. And that's also the department where I was hired at first. So I've also done, you can say, machines where you follow the project from whiteboard sketches to 3D drawings to something we build in the workshop, and then you program it and test it and all of that. But then there was this integration part afterwards, and suddenly I became like, yes. And I also found it quite interesting that to be in this world between OT and IT. So as I don't know, maybe 5-6 years ago, I like fully committed to say, okay, that is what I will focus on. That is this integration between OT and IT.
Some other companies would say, let's do it even MES. So like, I would say perhaps you had a little more hands-on approach at Velux, also building your own machines. So why not just, okay, let's buy SAP ME. Not sure if you perhaps also have it on the side, or if you want to share that, but if it's a way more hands-on integration approach, why you just not trust a vendor with that and just let him integrate ERP to the shop floor?
I think it's not like we don't use MES in Velux. We have just been doing it. I think each industry and each company is different, and you have to look at what you're producing and what is it actually that is driving you to do this integration. You can say Velux is a manufacturing company. We're not doing food or beverage or medicine. So you can say these regulation tories about tracing and all of that. We don't have that. So when we have done, you can say digitalization, we have done it where you can say where it makes sense for us to optimize our processes. Then we're doing windows, but we're doing, you can say, all the parts for the windows in our factories. So if you look at our factories, they are actually quite diverse. Has a really big difference in what we do in one plant to the other. So having a standard system might not be the right suit for us in all cases.
Yeah.
So, and then I think like many other companies, we've been trying a little bit here and there. Where is it actually we want to go when it comes to digitalization, and what is it that makes sense to do and not sense to do?
I think we're in a super lucky position, to be honest. Like a lot of manufacturers are a little bit stuck in, we buy machines, so like as package units or like as standard equipment, and then have like, I would say, limited capabilities on site to then connect those standard packages to the process and try to perhaps force on like a companion spec or whatever data model on top of the existing machines, but lacks the control on the machine side of things. And I would say you have a little bit of a hands-on approach, but also me see building the machine, so you now can focus on building the APIs from the machine to your systems in a way that makes sense to you. And I think you have a quite fortunate position to be in. And this is also something that a lot of listeners are hopefully, and I'm quite sure, are super interested in too, is like and how do you now define the APIs to the machine? So perhaps a bit hard to grasp on a podcast, but try to make it a little bit more audio visual into how do you now make these machines without those companion specs that were able to communicate effectively and scalably.
Yeah. What we have done, you can say, when we build machines, we are quite internally. So you can say in Velux, we don't do all the machines internally, we also buy a lot of machines. But when we build machines, we have some quite good standards on how we want to program, how we want to do our HMIs, and we use the PKML state model and the ESA hierarchy and stuff like that. And we've been doing that for, in all the 16 years I've been part of Velux, it's always been a journey on standardizing our OT layer. Very, very good. And also when we go buy machines, we also try to make external vendors use the same standards. Here's a little bit difference if you buy custom machinery or if you buy an off-the-shelf machine. But we try to if we can, we try to get also the externals to actually use the same building blocks as we do internally. So over the years, and this is really taking many, many years, but over the years we have created a quite good template and a library of PLC functions that we both use internally and use for the externals when they build a machine for us. What that gives us is also, as you say, this API, because then we don't just give them a specification on how to do it. We actually give them the building blocks to do it. So you have a function on how to communicate you, and what we show them is just a guide on how to do it. So that's you can say what I've seen. At least a very different way of doing it is because we're actually handing them the code and not just a really long text specification
which they don't understand, like this. So they give them like an request for proposal of the new machine and outline on 150 pages on how you would like to have the data modeled, and they were like, I have no idea what he wants from me, so it's too specific. And then on the glimpse, on the highest level, it's integrated in the way you wanted to do, but he didn't understand what you actually mean. So going one step further and saying, okay, how this PLC should be, and the functions and the data points should be implemented, it's actually way more tactical. And I think also where a lot of standards actually fall short. This is way too less tactical. Perhaps we have a little bit controversial opinion about OPCA. They did a lot of good things. I'm sure you don't want to jump on that train yet, but they are too specific, like 1,500 standard pages of how it should be done. Nobody understands it. And giving him more technical examples, it's really say, a glimpse of hope on how to communicate with the vendors. Yeah.
Yeah, and I normally say that when I have to explain it, that it's easy to connect to a machine.
Yep.
It's really, really easy to set up OPC connection or Modbus, or I don't know, TCP.
Doesn't matter. Yeah.
Really easy. It's really easy to create it, but it's so hard to actually get the context of the data. So when and what do you communicate, and how does it look like when you communicate over? And that doesn't matter what kind of communication protocol you use. Actually, there's none of those in the industry that we're talking here that's actually describing and giving you guidance on how do you communicate on this alarm, for instance. You have to figure that out by yourself. You have to figure out, okay, how should an alarm look in my context? Then you can try, and for many years we followed the PACML and the PACTAG, and also waiting for OPC UA and the companion specs, but it never really came. And again, I agree with you. The specifications you got that came out was either so specific and tailored for one industry that you couldn't use it. So you could use it for maybe that one beverage machine or whatever, but if you couldn't replicate it to a manufacturing machine that we had in Velux, or they were so wide that you couldn't use it for anything. So what we did was actually, I don't know, 8 years ago, we had again a lot of these projects. And then at one point, me and some colleagues, we say, okay, we cannot continue doing projects. We cannot, that every time we have this machine talking to this machine, that we have to start from a white piece of paper. We need to be able to reuse what we do. And back then there was one of my very good colleagues, Martin Skov. He actually already back then, and his background is from IT. He's a C# programmer. He knows nothing about PLC, but we were sitting next to each other, and he said, we need to do an event-based communication.
Nice.
And that was like way before anyone was talking about MQTT and anything. And we need to make the payloads like a JSON format. So already back then, he was wise enough to see that if we make this event-based, and if we make sure to translate the byte arrays from the PLC into JSON objects, then we have the flexibility to do what we want. And in the beginning, we were just creating standard SQL records, actually, with those JSON payloads. But then a little bit later, when MQTT came along, it was really, really easy for us to adapt to that.
Well, I really, really like that approach, because it's often this outside in that is, in my opinion, a bit lacking in the industry, because we are trying to cook our own soup always. So try to implement everything on our own. For example, OPC now also offers the ability to do PubSub. But why? There are established technologies out there, MQTT, Kafka, data streaming. And it just takes like an educated IT guy to say, what the fuck are you doing? Let's just use what already is working in banking and connected products and make it applicable for manufacturing, because on the paper it's like a distributed system with APIs, like machines that want to fetch and provide data, and there's a message broker just logical. And so very good that he's sitting right next to you.
Yeah, and that's one of the things where we have been lucky, is that we did a lot of we also do electronics in Velux, and we did a lot of internal software development for testing our own the electronics that we produced. And Martin, my colleague here, he was actually where he started working in Velux was actually doing testing software for the electronics, and that was more PC based. They had to use some kind of measuring equipment and collect data from different equipment, and then store these measurements in some SQLs, and do some analytics on it. So he was working a lot with that for many years. So he actually, you can say, from the IT as a programmer and C# programmer, was doing that, but also gained a lot of experience about machinery and processes, because what he did had to connect to that. And then you can say, then we teamed up, and me as a PLC programmer and another PLC programmer in Velux called Lasse, we had the other view on it, and then together you were actually able to create this framework that started it.
I like IT OT convergence done
Yeah.
right.
And we actually do this. That's one of the things I really still is very important for me that we do today. So back then we were 3 people working on it. Now in the Velux we're like more like 25. But the team we have that we call the VIP team that is working with this IoT platform we have in Velux, the team is a cross-functional team. So it's not placed in either IT or supply or OT, whatever you would call it. In those 25 people, I think we have like 4 different people managers actually. So we have people that are employed in the IT department. We have people that is employed in our supply organization where we have technology centers. So the PLC programmer, and we actually also have other people that is employed in a factory in another part of Eastern Europe and Western Europe. And that is for me really, really important that this is not that doing this, connecting OT with IT is not like an IT task or OT task. Had many discussions with colleagues in Denmark where it seems to become more an organizational fight if OT is owned by IT or if OT is owned by the factory, who is actually, instead of actually just like realizing you cannot own it. It's something in between. You need to own it together. You need to find solutions for this together.
I would also, it's also an interesting question up front. So how do you actually structure like plant-based people versus global people? Because a lot of customers and users of the UMH ask, how do I now set up like a dream team if I now need to ask my manager or like a global function on how I need to allocate resources? Do you have them like distributed across all sites, or do you have one champion per site who is understanding the system for whoever might ask questions or need hands-on help on the sites?
It's not that structured that you can say each factory where we have one on each factory. We don't have that, and it is. I will not say it's also a little bit hard to get this organization to work. So it also requires that you have some local managers and some people in the factories that also wants to work in this way and wants to join. But I would really love that you can say that we have people from the factories that is actually joining in and pitching in, co-creating on this platform that we have.
I would also
because
say
it's
I really like that you're like engaging the people that are already there. Like it's not about that you should hire somebody, put him there in place, and he's productive from day one. It's more like showing cool stuff that you are doing, either on the use case, the connectivity, or the technology basis, and then the right people from the organization will pop up. It's more like, why are you doing Kafka data streaming, or why are you using Grafana? This is cool. And then the maintenance, electrician, whatever, who is actually interested also pops up. This is also really good from people enablement and keeping technical high potential people also like interested in what you're working with.
That's at least the goal. Is we will, you can say, build a platform where you have some products that we can serve some solutions and some products that you can use if you want to in the factories, or we can help them. So we would really like to see if people have the skills to do their own Grafana dashboard or do their own small applications in Node-RED or data collection with Node-RED, for instance, and then that's fine. But also if you have more advanced users that will actually go directly on Kafka and play with KSQL or whatever, and then we can also serve that. I think you can say you have different skill levels depending on where you are and what you do. And also, if you're not doing this as your full-time job in the factory, then it might also be hard to keep up with. You can say the technologies are moving really, really fast. But we have now some factories, you can say, where they are building their own Grafana dashboards, and together with a local electrician, then the electrician can go around and do the data collection, and then you have a business analyst that has learned how to do the Grafana dashboards. And now you can say, as a team, we are not doing anything They are just self-running themselves,
Right.
doing the dashboards they want.
I think so also the ideal state, right? So you're providing the platform and keeping it up to date and working, and they do the use case. And this is also the ideal set of use case capturing, because there are, like, I would say, a few ones that you can say top management, let's do it globally, like OEE, energy monitoring, etc. But they're like the long tail of use case that nobody has actually an idea of that they need it except the local electrician, and enabling him with the tools to just do it, and then capture, I don't know, this few thousand euros per annual business value, but still relevant without having like a huge project overhead, etc., and building the long tail of use cases more on a grassroots movement approach.
Yeah, and that's actually one of, you can say, the key goals is that with the approach we have, where you could say one of the things that is very key to us is collecting the data from the shop floor. That is something we want to do internally in Velux. Which system we then use for looking at the data? If we now we said Grafana is an open source tool. I love it. It's the best tool for you can imagine for that. You cannot buy anything for the industry, I think, that is comparable at all. But then you have something like OE, as you also mentioned. You could do an OE calculation in Grafana, but you can also buy pretty good OE tools on the market with a lot of capabilities that probably would be a little bit hard to fit into Grafana. But the cool thing that with what we do, where you have we collect the data, we structure it on an MQTT program, we send it to, we replicate it to Kafka, is that it's the same data source. So the same data source that would go to that third-party OE system that we pay a license to have is the same data source that will go into our influx database, and you can create an open source dashboard on it.
Yeah.
And that, for me, that's actually where I see the biggest flexibility in what we have done, is that we have separated the producers and consumers. So if the consumers is a third-party app, if it's an app we build ourselves, or if it's an open source tool, we can actually freely choose that now. And for me, that's a really, really, I see big value in that, because what I've also seen in this industry, and when you go to the conferences, that the software you looked at 2 years ago might not be the software solution you look at today. It's changing so rapidly, and what you normally would pay someone some license for, like for a historian, now you can get it free with Grafana and Influx. So being able to change between vendors or between software solutions in the future, I think that's really, really key. And what I've seen is that too many manufacturing companies, they get a really, really hard login to one specific solution on one supplier.
Yeah. This is where I also see the UN as not on the short term enabler, but also the long term don't get logged in. It's a lot of people, however you want to name it, it's redoing the MES strategy. So saying, oh, we need to now a new MES because it's now 10 years old. We need to always everything new in 10 years. But then they're thinking, do we do MES-centric integration? So saying, let's push everything that to the internal database, and then do your, I don't know, RFC calls if you're on the SAP world, or whatever calls, if you're in another ecosystem. But I think having it more on the side and thinking about APIs first, and also buying only tools that provide APIs, then you can already challenge the vendors on that. Is a way moving forward. And it's not yet the case, and you commoditize on the way every feature that was actually already solved open source 10 years ago, so you can piggyback on that.
Yeah, and instead of having that, I think mesh systems can be okay for a lot of things, but what I like is if you have that capability list of 10 points in an MES system, but then why not, what you can say, what we do now is decoupling them. So you can say, okay, if that MES system does not give you the best OE system, then we just buy that capability somewhere else. Or and I think some of these tools that is coming now that is having a more narrow focus, maybe on only OE or only energy monitoring or
planning,
only quality, I think they are much more tailored for that need, instead of having a MES system that has to solve the whole capability stack. and the whole variety of machines that you will find in different kinds of industries, because they also have to serve a lot of different customers. I think that flexibility in the long run is very, very valuable. But it requires, I think the strategy we have requires a lot when you connect the machines in the beginning, because we have to spend a lot of effort on each
Make
machine.
it right, yeah.
Make it right at the first time to get that long-term benefit. And that can also be hard to explain sometimes to internally why we do it like we do it.
It's expensive, 25 people. Yeah.
Definitely.
Also, what I'm really, really looking forward to is a lot of manufacturing software is designed to be bought. Like you now have like an RFP sheet and you have like 15 functions that you want to enable: planning, energy monitoring, OEE, process analytics, whatever. But nothing of that is good. This is really, it's there to, on an RFP or on the procurement, tick the boxes. But as soon as you like really work with the tools on every segment, there's something better out there. There are like super specialized OEE tools. There are super great drill down energy monitoring tools, etc. They're like historians or perhaps modern open source time-series database to go into the process part. But I'm really looking forward to the future where it's more consumer focused. You buy about ease of use, scalability, etc., and really features inside the feature, and not only to make a product super wide to cater to the most boxes possible and then have an inferior experience on all of those boxes. This should be looking a good feature or future looking forward.
Yeah, exactly. And I really hope what we have done and what also what you can do with unified namespace, as you say, in the future is that you can actually go for what we call fit for purpose. You can go for the best technology out there fitting the capability that you're looking for. And also depending on what industry you are in, there are some capabilities that is more important than others. And yeah, so I think it was also think your approach. I saw read your blog the other day about this with the software and how it's that you say it's built for buying and not for the end user. We are really also try to some of the applications we do. We do some applications internally as well. One of the applications we do is a small application that where we show the orders we have from SAP, and then you can select it and send it to the machine and see the status live on where you are in your order. That's of course a very, very normal MES capability, but the way we use SAP and Velux and the way we plan our production, it was just a really, really small piece in the puzzle we were missing. It was just showing the orders at the operators, giving them the possibility to do some fine planning on the day if they were lacking raw materials or something for one order or two. And now we could tailor application for that. And when we did that, we actually went out and interviewed the operators and asked them, okay, how do you imagine this piece of software should look like? What functionalities should it have? And then we had a UX designer doing mock-ups of it. They could click around and give us input. Okay, how should the button looks? What colors should we use? All of that. And now we have a really, really cool application for that is totally tailored for that and nothing else. It doesn't have a lot of boxes, a lot of things you can do, but the UI is so intuitive that it's really, really easy to use for the operators.
To secure buy-in by that, yeah. So because this are the ultimate test of every solution is actually if the shop floor worker is saying behind your back this is actually completely useless, or if they're saying this is actually something that helps me, and by bringing them in early on and doesn't give him like this is the solution, now use it situation is, I think, super powerful to get also their buy-in and their love for the product. Kasper, like IT, OT convergence everywhere, but what do you really say tactically? What can IT learn from OT and what OT can learn from IT? So what's the tactical learning approach that you would recommend for everybody?
Wow. IT from OT, I think the main thing there is that IT people need to get a little bit closer to the OT. They need to go out there and see the machines and actually try and understand why some of the practices that they have been used to in the IT world, like CI/CD pipelines, can be extremely hard to implement in an OT world.
Feel the pain,
maybe
yeah.
you can, and I have had, you can say, several discussions with people that didn't really understand why is it so hard to update? Why can't you just update the PLC program now? Why do you have to wait for that? Or and all these dependencies that in the OT world, you have a lot of dependencies to hardware versions, software versions, and we try to, you can say, decouple it by having a microservice in front. But basically, if you have 1,000 machines, you have 1,000 different APIs you have to maintain. That's a little bit like how I see it, and it's extremely hard sometimes. And I think IT people really don't grasp that often. But I think what I've had positive experiences that when you find IT people that actually are curious and wants to go with you to that factory and actually try and understand it, then they actually see it. And I have my good colleague Henrik Krüger now, who is our lead cloud architect in Velux. He's also now suggesting different products for our pipelines, so how we can help us release software easily, because he can see, okay, we cannot do it in the same way as we have done with other, if it was like a web page or something, different app.
I think it's also the right terms that you need to use to IT. If you really want to kick them, it's a highly distributed system where consensus of messages is not guaranteed, so that it's actually like a hard thing to get. Let me crack that nut with IT tools. Yeah.
And and the other way around, what OT can learn from IT a lot, I would say. And I think there's a lot we could learn. For instance, the reference you had with why design a standard when you could actually just have picked MQTT. For me, I don't grasp that at all. Why is it that every time we have an issue in OT, let's invent the wheel instead of looking at what is actually on the market that we can use? And I think we've made it really hard to use these open source tools, to use these modern IT principles, because we feel that OT, it's so special. It has to be, you have to have a high availability. It has to be running for 10 years and all of that. But I think we forget that a lot of the IT we have today also has to have a really high reliability. And all of our banking, all of our financials are running on IT, and it's like, and sometimes it's when you hear people talk about OT and machines, it's like it's like they see that as even what would you say? That has to be even more reliant. It has to be, that's like the hardest thing ever, is to keep this high uptime on that machine. So it has to be really, really special. And open source is, of course, not an option, because you have to have
tinkering,
industrial grade hardware or whatever
to be
term they use.
Yeah.
Let's paint it yellow. And I was like, and I really think that looking at even with the cloud, you can say something like, I'm really inspired by the cloud native community, where you can see big banks and a lot of big companies using open source to run their business fully. And it's like, okay, if you can do it in a bank, if you can run a stockbroking platform on open source technology, I think we can also manage to do a little bit of data collection from a machine with the same principles.
The discussion about uptime is also a little bit strange when you talk about OT and IT. IT people say 99.9% is normally, and 99.99% if we really double our budget. And the OT says we are 100%, never failed. And the IT people, this cannot be true, not possible. Just looking barely not possible, but it never failed in my personal shift or whatever. And they're like, okay, there needs to be alignment of units of measurement here, but 99.99% is not enough, is then the answer. And this is what Google uses for every service. It's not possible to go beyond that point without spending billions, but no, 100% is a goal here.
I think that's also where the OT and IT world has needs to communicate better. I often say we need to set the expectations right when we talk to our customers in the factories, because when you do connect your machines to the IT layer, then there is one more thing that can go wrong. There's one more thing that can make that production stop. And again, 99.9 or 90.99.99, it's really, really hard to get to that point. It costs a lot of money. And but when people have an IT issue, I think that's just something that you can also see it with my kids. When their iPad suddenly stops working, they get frustrated because you don't know why. But when a machine has a mechanical failure, you can see it. You can see, okay, that cylinder got bended, or that motor didn't belt is now, I don't know, torn and it's not working. So you know why it's not working. But when something in IT fails, then the people at the machine, they don't understand the root cause, and I think that often creates a lot of frustration. And one of the things that we're talking a lot about in the team is actually being able to get that information directly to the operator at the machine, why the machine is stopped right now. Why is it that, okay, we have a network error. Oh, the order you're running has the wrong data from SAP, or I don't know, the printer is offline, or whatever. Those kind of everyday problems that happens when you work with IT, but there's some rather invisible to the people at the machine.
Yeah, the reasons.
Yeah, and that's really, really hard, and that can give your solutions and your a really, really bad reputation really, really, really quick, because for them it's just annoying. They don't understand what's going on in the background. And for us as developers, it's also really, really annoying, because often it's small things that you can actually fix quite quick, but then often the information might come to you 2 weeks later. Oh, we had an issue with that data for 2 weeks now, but no one told you, and that you could have fixed it very easily.
I think this is also like key of building a great product, to have enough feedback of what is bad as soon as possible to fix it actually for the long tail of all the other people. This is why we are like, the open source journey for us is actually, this is yielding another benefit. Yeah, so we have like a lot of downloads per week of people trying it out and stopping for a certain reason, or like using it in a certain way and failing at a certain technical problem. And we are collecting those anonymized metrics also from a system, and seeing people have a problem with OPC server type XYZ, and we can patch it on the fly without actually needing to talk to the people. It's also, people don't know that from manufacturing, that software is actually evolving in real time normally, but we try to provide it also via open source. That's why it's so powerful in our opinion. So I think we could talk even 4 more hours, but try to keep the attention high here, and really, really want to thank Kasper for sharing that. So if you want to learn more, feel free to reach out to me, or I hope also Kasper is fine if you contact him on any questions that you might have. And so really, really thank you, Kasper, and looking forward to continue your journey and continue the discussions.